that. Present my entire screen. Share. And back to here. All right. So there's 1, 2, and 3. There's 1, 2, and 3. Good with that? All right. Wrong side. Those are the ideas that should have been presented in your proof for the bottom two. For this, you would have the vertical angles, naming them either CAB and DAE or 1 and 2. Vertical angle property. Triangles are congruent by side angle side. And angle C is congruent to angle E by side. And then in the one underneath, they tell you M is the midpoint of BC, so by definition, midpoint, BM is congruent to MC. All right, shared side by reflexive property, these are given you. Triangles are congruent by side, 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 and the angles are congruent by CPC. All right, everybody good with those ideas presented? All right, go back to number 5. Good with that one? Obviously, they put the all right angles are congruent in 2 steps. That's how it differs, but it's up to you how you want to do that. And then for the last 2, all right, lines are parallel, they're not necessarily congruent. So these angles are going to be congruent by alternate inferior angles. You can name them with 3 letters or by numbers. Keep in mind, ladies and gentlemen, those aren't congruent because they do not touch the parallel sides. These are the given angles. Reflexive property gives you the one side. Because the side doesn't touch both angles, it's going to be angle side. And then BC would be congruent to BA by side. All right. And then the last one, ON bisects angle JOH. So you would say those 2 angles are congruent by definition of angle bisector. ON is the shared side. The 2 angles are congruent. Once again, the triangles would be congruent by angle side. I apologize, that S shouldn't have been there. And then the 2 segments JN and AHN are congruent by CPC. All right. All good? All right. So let's take it to the next step. I'm going to show you these proofs in 2-column format. There is no mandate that says you have to do them in 2-column format, but the more you get exposed to things, perhaps the more you get comfortable with them, perhaps you'll decide to take it. I'm a big fan of flowchart proofs, but again, that's completely up to you. They tell you AC bisects angle A. So those two angles are going to be congruent. All right. So those two angles are going to be congruent. All right. All right. So angle 1 is congruent to angle 2. AB is congruent to AD, that is given. And then AC is going to be our shared side. All right. So the two triangles that they're asking us to prove are going to be congruent by side angle side. All right. AC bisects angle A. Because it is given to you. As a result, deductive reasoning, if you're going to do a flowchart proof, goes in the second column. We would say angle 1 is congruent to angle 2, simply by definition of angle bisector. All right. Also given to you is AB is congruent to AD, because it is given to you. That's part of our triangle, so we don't need anything from that. And then they didn't give it to us, so we put it in the deductive reasoning column. We're going to say AC is congruent to AC by the reflexive property. All right. At that point, we bring those together. We draw arrows. Say the triangles are congruent. By side angle side, two sides and the included angle. And then yesterday's work. All right, number 2, B and D. Are B and D in the same location in our triangle congruency statement? They absolutely are. So we're allowed to say it. So we're going to say another arrow. Angle B is congruent to angle D. A CP. So whenever it asks you to prove segments or angles are congruent, that's how you're going to end CP. Now number 3 is a different ballgame, and that's what we're talking about today. Number 3 is not asking you to prove angles or segments are congruent. They're asking you to prove a definition. And with the 2 exceptions, that means your proof's going to end with definition of. So the key thing you have to be able to do, though, is recognize what gives us that definition. So this says CA bisects angle C. That's C. So that means these 2 angles would have to be what? For that angle to be bisected, those 2 angles would have to be what? Congruent. I'm going to call them 3 and 4. Are you still stating 2 segments or angles are congruent? Yeah, so your reason, just like yesterday, is still going to be CP. All right? So I'm going to say angle 3 is congruent to angle 4. CP. Then you're just going to add a step. And that step is what you're being asked to prove. And that is CA bisects angle C. And most of the time, all that is definition of. In this case, angle bisect. And you're done. Yeah. I'm going to be done with extra up by about 2:50. I'll be back here by around 2:50. Be back here around 250. So if you're staying for the Key Club meeting, your sister's going to be there?
Yeah.
Then she can bring you to the dentist and mom will meet you there. So here are your choices. You can be back here. Stop not making eye contact with me on purpose. I can't yet. So you can either be back here by 250 and you can tell the president of the Key Club you have to leave. Or you can go home with the president of the Key Club. Does that make sense? I'm leaving at 250. Make sense? Okay.
So,
All right. Does everybody understand how we prove definition? You're adding a step. Okay, now on the back. The two exceptions are parallel lines and perpendicular lines. So in the third one, you're going to be adding prove. RT is perpendicular to SU. So that's what you're adding in that proof. All right. So here's what you're going to do. It's saying you have to prove HG is parallel to EF in the one on the left. Right? HG is parallel to EF. I'm not you, but if I was, I would darken in the lines you're trying to prove parallel. Now, earlier in the year, when lines were parallel, we had special angle pairs that were congruent. Alternate here, alternate exterior. Right? Those angles were created by what special named line? What line do we call the one that creates those angles? All right, so you're looking for the transversal, the one that touches both lines. Which line is that? JG, JE, JK, however you want to name it. So that's your transversal. So what you want to do is you want to find angles that do two things. One, they got to hit that transversal. And then they could be either alternate interiors, alternate exteriors, corresponding. But those angles also have to be part of the triangle. Can you see the two triangles that we're going to utilize in the diagram? Okay, that's what we're going to start with triangles. So what we need to do is figure out what those angles are. And that's this one and that one. Okay? These two angles, okay, either don't touch the transversal or don't touch the parallel line. We're not going to use those. Make sense? You got to figure out which one to use. Now, all right? Based upon the parallel lines, what vocab word defines those two angles? Alternate what? Be careful. Look at your two lines. Where the best location is. Not going to be interior or outside. Those spots. That's not even normal. Alternate exterior. So I already know how much we should add. You said. When I say HG is parallel to EF, I know it's going to end with alternate exterior angle. Which of the alternate exterior angles? This angle and that angle. From what you did last night and what we did at the beginning of class, what are you going to say about those two angles? How are you going to say they're congruent? What 5 magic letters? CP, CT, C. So I already know before I've done anything else how much it's going to end. It's 4 points. 4 points. I know it's going to end. Now, we have to put together the rest. All right? Step 1. All right? Angle 1, congruent to angle 2. Because it is given. All right? All right, angle 1 and 2 inside the triangle. Are angle 1 and 2 angles of the triangle? No, so we cannot directly use them. We have to use deductive reasoning. What do angle 1 and 2 form with one pair of the angles that are actually inside the triangle? What vocab term? What? Linear pairs. And by definition, linear pairs are what? Supplementary. So what we're going to do is we're going to call this 3 and this 4. Bye, Brooke.
See you at 6.
Yes, you will. So we're going to say angle 3, congruent to angle 4, congruent supplement theorem. All right. All good? Yeah. They themselves don't form a linear pair, but they form a linear pair of congruent angles. Make sense? So 4 forms a linear pair with 2, 3 forms a linear pair with 1. So by definition, by congruent supplement theorem, they're going to be congruent. I think that's good. Okay. So the next piece of information is that angle H congruent to angle F, also given you. All right. Are those angles inside the triangle? Yep, so you're done. You don't do anything else with them, it's already given. Then we have JG congruent to EK. That is also what? See you then Thursday. Do you need the consent forms or no?
No, they can say it.
Okay. Here, later. There's JG and EK. Are they part of the triangle? Yep. So I'm good. I got 2 angles on the side. Does my side touch both angles? You can't include these. You're not allowed. We haven't proved they're congruent yet. So they're not congruent yet. My congruent angles are there and there. There's my side. Does my side touch both of the angles? No. So what's it got to be? Angle, side. Make sure your order is correct. Triangle JGH congruent to triangle KEF. Angle side. All right. Now this is when our initial thoughts kick in. Call that 5, call that 6. They're the remaining angles in the triangle. So angle 5 is congruent to angle 6. CP, CTC. Now, based upon what you already knew, did you need to know the triangles were congruent to know those angles were congruent? No. What theorem could you have used for an angle? Well, we're practicing these, so we'll need to go through the process. Triangle 5 is congruent to angle 6. Therefore, HG parallel to EF, alternate exterior angles. All right. It's not always going to be alternate exterior angles. If you have that diagram and you're trying to prove these 2 lines are parallel, then we're going to go with those. Those aren't alternate exterior. What are they? Alternate interior. All right. If I'm trying to prove these 2 lines are congruent, then it's that angle and that angle. One's interior and one's exterior. What do we call those? Corresponding. So it's not one set way. So with parallel lines, it's not more steps. It's just knowing which angle to use. All right. What I want you to do in that one, please, is just prove the triangles are congruent. Just prove the 2 triangles are congruent. you can, I mean, this is fine. I don't have to get help. Yeah, that's fine. Yeah, I'm impressed. These are the approved sale for homeowners. The world is dream. All right. Now, with proving lines perpendicular, you don't have the same dilemma you had with parallel lines. And that you can tell by looking at it which two angles you're going to try to prove congruent. Correct? Because what do they form? They form a linear pair. They add up to what? 180. If they're congruent, they're exactly the thing. 180 divided by 2 would be 90, which makes for what kind of angle? Right angle. And we need right angles to prove lines are what? Perpendicular. The difference with this and why it's not as straightforward as the others is there's a couple steps involved. So step 1 is identifying which angles we need to prove are right angles. That's 3 and 4. Now, the fact the triangles are congruent visually tells us they're right angles, but we don't know it for sure yet. So we got to say angle 3 is congruent to angle 4. And just like all the proofs we did yesterday and earlier today, what 5 letters are going to tell us that? CP, CTC. Here's the part you got to add in the middle. Otherwise, there's a flaw in your proof. Angles 3 and 4 are right angles. Now, you have a choice. I will gladly accept linear pair property. Because if you say linear pair property, you are showing me you understand that the angles form a linear pair, they must be 180. And if they're congruent, 180 divided by 2 is no. So that's the abbreviated version. If you forget that, then you have to describe what's happening. You have to say, if two angles forming a linear pair are congruent, they must be right angles. It's your choice. Alright, so you can either write what's happening or you can abbreviate it with linear pair property. And then you end with RS, congruent to RU, definition of perpendicular line. Good? Good? Okay. So, your homework this evening involves, like I said, 8 proofs. You can write them in any format you like. In the first one, you have to prove A is the midpoint of CE. If A is the midpoint of CE, then what 2 segments have to be congruent? If A is the midpoint of CE, what 2 segments would have to be congruent? AC and what? AE. How are you going to say they're congruent? By what 5 magic letters? CP, CTC. The one underneath Now you have to prove the lines are parallel. What kind of angle do you think you're going to use for that one? Alternate tiers. Because they're going to be inside the two lines. All right? Now, the last thing I'm going to say, and then you got a few minutes to get started. This one's a little different than the one we just did. You not only have to prove it's perpendicular, you also have to prove it's the what? Bisector. So in addition to what we just did, when you prove those angles were congruent, what do you have to say about those two segments as well? They also have to do what? And you can do that with what 5 magic letters? CPC. So each of these, unlike last night, you go one step past, at least one step past. All right? We'll go over tomorrow, and then we'll start 4.5. I saw 3 triangles.